instead I'm going to talk a little bit about mocking. It's mostly about something that I only learned about 2 or 3 weeks ago. When I found it, I felt really damn stupid. I hadn't heard anybody talk about it before. So who knows, maybe you guys will feel the same way at the end of this talk. Just wanted to quickly do a little promotion for an event called Swift Island. It's going to be 4th and 5th of July. We're going to be hosting a mentoring session there. You're going?
Yeah, going. Also, they're sold out.
Yeah. They're sold out? Yes. What a heroes, aren't they? Everybody pretends like he didn't say that and go ask them for more tickets, who knows? So yeah, that's going to be awesome. Everybody who doesn't have to take them, I'm sorry. So the name of my talk today is the testing games, mocking, yay, maybe must be up in your favor. Came up with it because it seems like mocking stuff, especially JSON, is something that it's kind of difficult and annoying and frustrating and a bit of a stupid chore to work on. So yeah, that's what I'm going to be talking about. Now, I like testing. Maybe a little bit weird in that case, because I like it a lot because it allows me to prove my code works. One of the things I dislike most is when somebody comes up to me and says like, hey, does this part of the app work? And I'm like, should work. I saw it work like 3 weeks ago. And then when you think about it, you go to the doctor and he grabs his tools. Like, are you sure the tools works? Like, the last guy didn't get sick, so should be fine. I like to make sure that something works and everything's fine. But I'm also a little bit lazy, so when I write my tests and things become annoying and I have to write up for the 3rd or 4th error case, I'm like, I want to go out and collect some JSON that pretends that the API just had an error and implement that in my test and then check for it and write the same check that I wrote 10 times already and then do it again and again and again until I have all 20 error cases. And I know that most of my colleagues are the same, and I suspect that most of you are also the same. At some point you're like, okay, it's enough. I kind of know that I might have endless errors. And in the worst case, I have my default error case, and that will say something went wrong, I don't know what, so try again later. Fine. But yeah, the product that I work on is an SDK that a lot of developers use internally at the company I work for. So we really don't get away with saying, well, we know these 2 cases work and you'll get something in the other cases. All that developers want to know exactly what went wrong, what to tell the users, and how to fix it. So I set out to improve our tests. So one thing I did was create a set of guidelines. And that doesn't really have a lot to do with mocking, but it was quite important because I think guidelines help to determine if something is good or not. Of course, it's very subjective, but if all developers on the team agree that this set of guidelines will be followed, a lot of future discussions can be solved for saying, hey, we all agree on the guidelines, we can do it differently, but we'll have to open the discussion on the guidelines. That's one thing that we did. The second thing is to update Quick a little bit. Actually got a lot of help with that today because we were implementing a bit of a gherkin cucumber style test with given, when, and then, which Quick almost supports, but not really. And luckily we found got some help with code snippet today that helps us implement that in a way that we don't like. And then third thing, which is the thing that I want to talk about today, is change the way that we think about mocking. Now, to give you a little bit of an idea of what our tests looked like before and what we were going for, this would basically be the test that we have. It's not too bad. If you guys don't know Quick, I'll give you guys a quick run through everything, and Quick is in the spec. That's the whole test. And you give a little bit of information about what you're testing using keywords, describe, context, and it. In this case, you describe the service, and it should log in. Could be worse. What kind of service? I don't know, but it's a service and it should log in. So could be worse. But this isn't a full test, of course. This isn't test anything. So the full test would maybe look a bit more like this. Now, what I think when I see this is hard to read. There's all this indentation going on. There's a lot of strings in there. There's a lot of stuff in different places. All the values are hard-coded. I mean, look at that, with username, Donny, password, and then expect the user to have a name, Donny. Apparently I decided that my user should be called that. JSON is inline, so this is the server response right there. And, well, again, the values are hard-coded, so if JSON changes for whatever reason, then I would have to change my username there. And I really don't like seeing this sort of stuff. So I just showed you that little bit of inline JSON, but of course in a test you get this kind of error, and then you get another error, and then maybe some more errors. And I mean, this would get a little bit annoying to have to type out all the time. And then imagine that for some reason the backend team decides that you could have multiple errors, and then all of this would change. And no, it's not really getting any better at this point. So I guess you could say, like, this is not what I wanted. There we go. Because you could say that when you get to this point, you have a full API response, paste all of this in your test code. It's not very nice. You know, it's actually a bit ugly. And then you could always just use fixtures, of course. It's the fix for everything, isn't it? It's even in the name of the thing. It's fixtures. So you change your tests to something like this. Put all the errors and all the responses, all the large stuff in the files that you load in your tests, and they're gone now. You know, instead of having this inline JSON, you get this. But you have just created another problem for yourself, because there is still, there used to be this, do this, there's still these hard-coded values, right? I mean, you still say that your user should have this name, which is a string, and anything could change in your JSON files, and your tests are failing because your JSON changed, but no logic really changed. It's just somebody who decided that the user should have a different name. So I thought about this for a little while, like, how can we fix this? How can we solve this? What would be a good way? Because actually this is the point where sometimes I would just stop writing a certain test and be like, okay, this is getting too annoying with all these different hard-coded values. It's becoming a chore to write, let alone maintain. So then I thought, we use Codeable for everything, right? We take JSON, and then we use decodable, and then we turn something, let's say, into a user. It's very easy. Just have this API response, its data, and turn it into whatever thing is decodable. So why not do this? Go from the user, use encodable, back to your JSON. Create an instance of the user, make data out of it, feed that through your API, make sure that everything still works. Oh yeah. Easy. That's it. No, it's not. So now I would say we're getting somewhere. Right? Your test could now become, you create an instance of a user, which we call a mock user. You encode that into data. Then you create your mock API, which you will make sure that it returns the user data for whatever call happens. You create your authentication service, you try to log in. But now you have something to compare your output, so you can say. So when I do this API call and I get this user out of it, it should still be the same user, even though you put it through the whole thing you want to do with your data. But you can imagine that we're not quite there yet. So if you look at this, a little look at how all these things relate to each other. Imagine creating an instance of this in your test, right? You want to create an instance of play response that has a game and a play. You're going to have to make a bunch of prices, a bunch of plays, huge initializer. So we need to do a little bit more than what we've already done, which is final steps. So you have this protocol, Mockable. And anything that's codable should conform to that in your app. And you give that an associated type, the base type, which is decodable. There's a reason I picked decodable there. It's because in the SDK that I work on, we want to make sure that app developers don't take objects and accidentally, for whatever reason, encode them and store them somewhere. So we don't intend something to be encoded back into data. We don't want to give the impression that it's something that's fine to do. So we make sure to only make these things decodable. For mocking, the base type only has to be decodable because it needs to convert something into itself and not into JSON. So you give that this small extension. And what it does is it's quite small, it's quite simple, which is why I thought it's like, holy shit, why didn't I do this before? Because you can just say like, hey, turn yourself into data because you are codable. Make yourself into data. Or turn yourself into a base type, which is convenient if you want to sort of quickly make sure that everything works. If you want to test it, of course, as well. Kind of convert this directly into from a mock user to a user. So what does this look like? So we had this code before with the game and the play response. It's a bit of a chore to manually copy all the properties. I agree. As you can see, for instance, let's look at the mock play response. It has this type alias base type, which is a play response. Now the play response is the one that we saw before. It's the struct with the same properties. The difference is that here everything is a variable. The reason everything is a variable here is that you might want to create a play response that has no current play to see what your app does, then change it to have a play to see what the app does in that case. So you want to be able to change this mock as you go. It's quite nice to be able to do this instead of having to load a new thing all the time. And of course, everything has a default value. So if you want to create instances of it, it will be very easy because everything already has a value right away without getting in the way of your app. I mean, I do agree that this is a lot of work. I did it for our SDK for all of the structs. It took me about a day. But after that, I could just remove, I think it was 50 pieces of JSON scattered in either text strings or files or just weird ways that it was included. So what do we have with this mockable idea? First of all, we have mutable clones of all the models. That means that you have this user model and it has a mock user counterpart, which is mutable. So you can change the username to see if that works. You can remove the username if you want to, if it's nullable on your mock, which is perfectly valid. Like the mock doesn't have to perfectly mimic your true model, which actually sometimes you don't even want, because let's say you have this enum, which does some complex parsing in your decoding logic. You want your mock to be close to the JSON, not to your final model. It also gives us sensible default values. So instead of coming up with default values on the fly and checking those hard-coded strings every time, you now have an instance of a class to compare with. So you can say, like, does my parsed user have the same username as my mocked user? And all the objects are ready to be encoded into JSON. So just set up a base, encode it to JSON, run it through your API logic, see if it comes out as you expect at the other end. Now change it a little bit, do it again, see if that also works. Change it a little bit again, see if that works. So you can imagine in the case of errors, you now create an instance of an error. You just change properties on it all the time and then see if that turns into the error instance that you expected. And it also gives you some spare time because you don't have to collect mocks for each configuration. And as I said, you also have typo-free comparisons, because you're not typing any strings anymore, you're just comparing mocks to objects. Bad pun right there, not a mocking nice. But this is sort of what I ended up with in some cases. I could just create a mock game, extract its data, create a mock game API, make sure that it always returns the game data, and then just make sure that what comes out at the other end is parsed correctly. Now imagine making it a lot more complicated, because the default had no prices, no place, everything was empty arrays. You want to fill those? Fine, you don't need to create a new mock. You don't have to go to your backend guys and tell them to create a new mock for you, or somehow make sure that you get the right configuration out, which can be quite difficult if you have variable data. So you can just create your own stuff, make data out of it, run it through the API, test it. So I have found in my tests that the fact that I can now easier configure them more easily encourages me to go deeper in my test, to make sure that I test everything instead of test the stuff that's easy to acquire. So, of course, not everything is easier, not everything is solved. One instance that I found is that it's really hard to test what happens if the JSON is malformed. Let's say your backend guys are not sending the first 3 characters, so not sending an opening quote and an opening curly brace. What should you do then? This sort of takes away your possibility to do that, because you're not working with hard-coded strings anymore. But in those cases, of course, you still have the option to create a JSON file. Or you could even do something where instead of going straight to data, you go from data to a string, mess up the string, and turn the string back into data. You still don't have any hard-coded JSON, you just have a malformed JSON output that you cannot really see because it's hidden, but it still works. This also was the thing that I was in a bit of trouble with. You cannot purposefully omit properties. So let's say you expect your user to have at least an ID, a username, and an email. Sometimes, for some reason, the backend doesn't send an email. It's not easy to do this, because if your mock user has these 3 properties, then it will of course always be in the JSON. Even if it's nullable, it will be there, but it will have a null value. The possible solution is to create a new mock class with your user and omit that value or that property, but yeah, it's not awesome to do that. Luckily, I don't think it happens very often that you need to test this sort of stuff, but something to think about. And this is another thing that I thought could be an issue for some people. You still need some place that tells you what a model looks like. Like, you can come up with it on your own, but if your backend changes something, your tests and the actual backend could be out of sync. What you could do, of course, is to try and set up something with the backend team where they provide an endpoint where you can fetch all the blueprints for all the models from. So they would just tell you, like, this is what a user looks like, this is what a broadcast looks like, this is what a TV show looks like. So you can use that to verify the job. Mocks that you wrote are still valid for the backend. There's a couple of things that I want to leave you guys with in general with mocking stuff and testing stuff. One thing I found is that if your API returns model instances, so let's say log in a user and then you get a user or an error back, that's really hard to test with, because your API needs to do all the conversion logic. It's easier to have your API return data and then have another place convert the data into whatever you want it to be. Because at that point it's just simpler to get in between what data is sent to through your API. Make small services. So instead of creating one huge API protocol, make an authentication service, make whatever you can come up with, make a friend request service or whatever. Of course, in your app, you could conform to all the protocols at once. You still have your huge API class if you like that. But it's easier to mock things if they're tiny. It's easier to understand them. Of course, tests shouldn't rely on a network connection. I think everybody agrees with that. The less dependencies your tests have, the better.
Depends on the test.
if you're testing what happens if there is no network or there is no protocol, that would be an integration test probably. Typically, don't do it if you don't need to. Obviously, this is not a silver bullet. I mean, there's always better stuff, there's always different stuff. There's always cases where this works well, cases where it works not so well. And large complex configurations can still be fed to Mockable objects. By that I mean that if you have something that's, even with all these sensible defaults, is a pain in the ass to instantiate, to create all these instances of stuff and tie them together, there's nothing stopping you from taking a JSON file in those cases and running them through your Mockable protocol stuff. The nice thing if you do that is that you can afterwards mutate values on this large complex configuration. So yeah, that's really it for this mocking talk. I hope you guys learned little things like I did when I figured all this out. I can imagine there's a bunch of questions because it's a lot to take in. So yeah. Yes.
Thanks for the talk.